For this project, we're going to make a sheet metal toolbox here in the Tyler shop. It's going to teach you some basic skills on layout, how to make accurate layout using a scribe and some layout fluid, as well as a combo square and other straight edges. We'll also get into how to cut out the material using two different methods, using an angle grinder with a cutoff wheel. We'll also explore using the bandsaw. We'll also tune up our cuts using a file, fold our parts up using the box and pan brake, and explore three different welding options. The MIG welder. We'll also take a look at how to do a corner with the TIG welder, and we'll also explore using the resistance spot welder to assemble the box so that you'll have a complete project with a few different methods for joining it together. So follow along and you'll have this tool caddy that you can use to carry all your smaller items around the shop. To start off with, we're going to need a sheet metal blank, two in fact. The first one is going to be 25 inches wide by 10 inches, and we're going to be using 16 gauge material. In this instance, it is either 1/16 inch thick or 060 by some vernacular, and it is just cold rolled mild steel. This is your layout. You might want to take a screenshot of this so that you can replicate it using scribe lines, but here it is in just Sharpie so that you can see. I used some of this die-chem. It comes in a spray can. It comes in a little bottle form as well. It's already dry and on that part, and we're going to do that earlier layout that you saw, and I'm going to use a combination square set to 2 inches, and I'm just going to make two tick marks from the long edges, the two long edges, and then connect them with a straight edge. I happen to have a framing square handy, and so I'm going to be using that in this video, and you can see the layout fluid allows for those scribe lines to show up very easily and makes it much more visible when you're cutting using whatever method it might be. It's a very accurate line, and it doesn't fade off or burn off, and your scribe doesn't really get dull unless you're abusing it, so you get a very clean layout. So we've got the two long edges 2 inches apart, and then those next two marks from either end are going to start at 4.5 inches, and then I'm going to set it again at 2.5 inches rather, and that'll give me that common 2-inch rim, and then a 2.5 inch bump out above for about where the handle goes. I'm going to find the center of the two short legs by setting my combo square to 5 inches and measuring from either side to take up any inaccuracies. And in this instance, I'm using a grinder nut to kind of put a little radius at that center point, and that's just going to give the top of the box a softer look. If you'd like, you can leave 1.5 inches flat on the top of the box. I'm just using what I have handy and available in the shop. Then we're going to connect the tangent of that little radius to that 2.5 inch mark. That 2.5 inch mark is also 2 inches from the long leg, and we'll create that look of the top of the box, that little angled top of the box. So take your time with the layout. If it's inaccurate, it is going to be a real problem later on when you're trying to fold this part up. So really take your time with the layout. It looks like I'm speeding through it, but I've edited this down so that it won't take up too much of the video time. Another really handy tip here is before you go cutting this material out, to make it real clear what's scrap and what's the save side of the line, the part that I want to keep, I went through with a Sharpie and marked those edges off. Second piece of sheet metal is going to measure 17 7/8 by 3.5 inches, and that's going to become this top little handle tray, and its layout is going to be pretty simple. really you just have one setting to do on the combination square, and that's 1 inch. And you're going to have that 1 inch mark or line from each edge of the sheet metal blank if you have a correctly sized part. Here's the application of that Sprayon Layout fluid. It goes real fast. You'll probably want to do it in a well ventilated area and then let it dry before you go trying to put marks on there. So same method as before, using the scribe to just make 2 little tick marks at either end of the part, and we'll just do that from each outside edge of this sheet metal, and then we'll connect them using the straight edge. I happen to have the framing square there, but it could just be a ruler, a long ruler or other straight edge that you might have laying around the shop. Again, really take your time to line these up. Of course, you would want to make sure that your part is square before you go assuming that it's square. So the square might be handy depending on how your blank was prepared. This one was prepared back at a professional shop on a large industrial shear, so I know the edges are good and true. So here's the layout for that top handle. First method of cutting is pretty basic. We've got a backer nut on the angle grinder here, and then we're going to use a 16, or I should say about a 1/16 cutoff wheel, and then using that arbor nut with the recessed side down. I have a video on how to assemble those grinders. Line up your line with the edge of the table, and of course always secure your part before bringing an angle grinder to it. You always want 2 hands on that angle grinder, and you'll want gloves on those hands, and wear some sort of a fire protection. So I've got a fire retardant shirt and of course a face shield on. You want to ease that wheel into the part. You never want to make sudden movements with a cutoff wheel on a sheet metal part, and just take your time with this. The face shield also allows you to really see your line well, so you can put yourself partially in the line of fire while all those sparks are bouncing around. Your eyes will be protected, so wear safety glasses underneath that face shield as well, and just ease into that part, and before you know it, you'll have a well cut part. Now there's going to be some pretty sharp and deadly burrs on there. Most of them are on the bottom of the part, but you are definitely going to need to take some time with a file, maybe a little bit of sandpaper or emery cloth, and tune up those edges so that they're not going to cut anyone later on. So I've just taken off the real sharp burrs with that cut. Option 2, if it's available, is the vertical bandsaw. It's a vertical metal cutting bandsaw, and I've got a scrap piece of plywood here. Happens to be 1/2 inch plywood. However, I would have preferred some masonite if we had it. It just tends to be a little more dense, and this is going to give me a 0 clearance insert. I've just fed it a little bit into the blade there, and then stopped the machine, and then clamped that piece of wood down to the far corner. Next thing we're going to do is, with the blade running, use a little bit of stick wax. Some lubrication on that cutting edge makes the blade last a bit longer. And another thing that makes the blade last a little longer is being real easy and steady about how you're feeding that part in. You don't want to feed too quickly, otherwise you could jam up some of those teeth. So take your time with this. That piece of wood underneath it is allowing for that relatively thin piece of material to be fully supported underneath the cutting surface. The insert that is native to the machine usually has a little bit of a gap between the table and the blade itself, and so some of these thinner metals can kind of bend or get misshapen, and you'll get a lot of distortion at the edges. So putting a piece of wood under your part while you're cutting in a well secured piece of wood is just a little trick to keep those cuts a little cleaner. Cut out your blanks like so, with these corner pieces, these little rectangles that wind up being, a little under 2 inches by about 4.5 or so. And what I'm doing is I'm just scribing a line at the halfway point down the center there. And if you'd like, you can also put a little radius or chamfer on the edge. These are going to become, if you use the spot welder, your corner tabs, and they'll be real handy to keep around. And so one, I'm going to use this nut to kind of again give myself a little bit of a radius, and the other one I just marked a little angled line. We'll see those turn up a little later. We've also got the handle to tune up here as well. We'll need to remove those 4 1-inch squares from the corner of that handle and that upper handle tray. And so same method as before, we're just going to take our time, feed that in there. If we're not quite on our line, it's okay to leave a little bit of extra material on the far side, and we could always clean it up with a file later. Here you're going to see this part get caught in the plywood there. So what I do is I stop the machine, I fish out that part with a gloved hand because it could be sharp. I'm going to start the machine back up and just feed in a little deeper with that piece of wood to a fresh piece now, so that I have good support once again, and then reclamp that far corner, and now you're ready to keep cutting. So that's what you do if the wood starts to get a little worn out underneath you. And then with all 4 of those little corners cut off, you can bring it over to the disc sander. Make sure you wear a face shield. You could do all this work with a file too, or an angle grinder with a light sanding disc, but this will make pretty quick work of it. And I'm just going to put the radius on there because the bandsaw is generally better for cutting straighter lines. Obviously not the straightest lines depending on the operator, but it won't do those like tight radii and radiuses. And so I can also tune up any other easy to get to edges. Those inside corners I'm going to have to do with a file later, or an angle grinder very carefully. I'm going to prefer a file method. And of course always make sure that you keep your part flat on the table on this disc sander on the down side of the spin always. So this one could be a pretty dangerous machine. Those inside corners and the edges themselves, you'll want to do some fine tuning with a file. I sped this portion of the video up just because it took a little while, but I wanted you to see just about how much work it takes to tune up a part like this. So I'm making sure to get all of those edges that will later be exposed on the finished box, and make sure that they're real soft and rounded over, because they're going to be real hard to get to later on after it's all folded together and or welded together. So feel it first with a light gloved hand, and then you could also feel it real carefully with a non-gloved hand, and then of course take your time. This is a safe edge file here, meaning that it doesn't have cutting serrations on one edge face of it, which allows me to tune up those corners pretty well. And of course take your time with all those exposed portions, and deburr anything that might be a little sharp. Now we can take it over to the box and pan brake once it's deburred and our edges are nice and tuned up. And I'm going to measure the fingers of this box and pan brake, the tooling of it. And it's a really good idea to come over and measure the brake before you go designing your own custom parts for other projects, because we have a limited amount of tooling. So in this instance, that 1.5 inch, or I should say that 1.5 inch finger is going to be in the way a little later, so I just moved it aside with the supplied Allen wrench nice and carefully. Make sure that it doesn't go in misaligned, and don't lose any parts. So we clamp it into the machine using those little yellow handles right on our scribe line, and then carefully fold it to a 90-degree bend. You may actually want to do the opposite of what I did here and fold the long edges first, and then do those shorter legs. We do have a 6-inch die on the machine, but In this instance, you can fold them both on that 16-inch die, and it should nest in there. In fact, if it doesn't, then you're going to have a little harder time fitting that handle in later. And so you might need to help it along to make sure it clears the outside edges of that 16-inch die. And you'll also notice that this part at about 4.5 inch on that side tall leg is about as much as you can stuff in that machine before it starts to interfere with itself. And I'm sure having that radius at the top allows me to get away with a little bit more. So think about how the design of your parts are going to go, and really take your time with this part in terms of lining up right on that scribe line before you go folding the parts into place. So this is the last bend. You won't be able to completely get it to 90 on those last two legs. That's why I say folding the 16-inch leg first might be a little better, because it'll be a little easier to correct that shorter leg, that 6-inch leg. Now we've got those two tabs. You may want to do this times 4. If you have 4 tabs, you can do the 4 corners using the spot welder method. So I'm over here. You can see how I already cut out and radiused and softened the edges of those outside tabs. I'm going to put them on the outside, and of course always check your parts with a square as you're going, and adjust them as needed. And so now here's another possible style of a corner tab. I just knocked an angle on that end. The main thing is you don't want any sharp edges, because as you're handling this thing later, sharp edges can be a problem, get caught on things and possibly cut you. So you may want to do 4 tabs. Here we are with the top tray / handle, and you're going to definitely need to bend the long side first on this one, and that's because it is slightly smaller than 16 inches, and those 2 little 1.5-inch tabs on the ends would interfere otherwise. So here I am bending that longer leg, leg which is about an 1/8 inch or so shorter than 16 inches, and then you can see I kind of overbent it a little bit. Here's how we can correct that. On a short leg like this that's only minorly overbent, you may have the ability to, using the clamping force of the machine itself, just bump it a little bit, and you might be able to open up a bend, at least a shallow bend like this, meaning that it's only got a 1-inch leg on there, so I can fit it back in the machine upside down. You could always take it to a piece of pipe and give it a few taps as well. We have those large radius column corners that might serve a good purpose for that. I'm going to take a little bit more time bending this next side. I don't want to overbend it and have to stuff it back in the machine. I may not be able to, so here I check it as I go, and now it looks pretty good. So now you can bend those 2 short legs, and you'll need to use the 1.5-inch die just sort of on its own in the middle of the machine there. This is again 16 gauge material. This is as thick as you can bend on this machine. Any thicker and you're liable to break the fingers and the dies and bend them out of shape. And so you'll want to be kind of careful with, especially that little 1.5-inch one can't take a ton of force. And so here I'm bending that up, and you'll see that my corners wind up looking a little mangled here, but that's a good learning opportunity. So what we're going to do is bring it back over to the bench, and I'm going to give it a few taps, firm taps on just the corner. It's hard to tell here, but I'm letting my hammer only contact that bent corner and using the support of the table. If it gets a little overbent, I can then fish in there with a wrench or clamp it, a couple of pieces of sheet metal together, and you can sort of open it back up a little bit more accurately. And that other corner looks a little funny too, so I'm going to give it a few taps. And this one, you want to make that part fit into your tray pretty well. So in this instance, I needed to kind of stuff it as far in there as it would allow, and then another little tap on that top corner, and I should have a good looking part here. So you can see with a little bit of patience, you can kind of get those corners tuned up and where they need to be. So the next operation we'll do here is to weld those corners. So I'm going to use this piece of aluminum as a chill block as well as a heat sink. And it also, because it's nice large square here, I can also use it as a clamping or fixturing block. So I'm just going to clamp the two legs together and close up that extra bit of bend that I needed to close up. And if you need to, you can do a few light taps on the corner there to tune up it as well. On the Miller 250, you're going to want to set the machine to its chart settings at 16 gauge or 1/16, and so set your wire speed and voltage accordingly, and of course always make sure that you're on the full range on that Miller 250, and set that machine up appropriately. If you're at the 350, it has some different settings on its chart, so make sure that you're using the appropriate chart for the appropriate machine. When you're turning on the 350, it usually takes a minute for that on switch for the machine to kind of cycle on and boot up, and then we'll dial in the settings that the chart recommends, which happens to be 16 volts on this 350 machine and a wire speed of about 155. It's a good starting point. See what works for you. Maybe do a few test welds. When you're welding, this is the method I would recommend on thin material like this. We've got a chill block, and what I'm doing is a series of small tacks just right next to one another, and I'm giving that material a moment or two to cool off until it's no longer glowing red. And I'll just put each tack right next to the other one, and you can stitch it together up or down, and that's your result. The heat sink really helps keep the any excess heat from burning through the part. The TIG is another option for more advanced or adventurous welders in our shop. If you're learning, the way you set up the TIG is to make sure it's on the steel setting, the electrode negative, and we've got some little pieces of orange tape on the machine. Make sure the lights are next to the orange tape for just sort of a dummy setting, and I've got it at about 100 amps. The tungsten is a 3/32, that is nice and sharp. You could do it with a 16th tungsten as well, and I'm using a number 7 or a number 8 gas lens, and your amperage might vary. I've got it set at the machine to 100 amps. You might go as low as 60. And my filler rod, I'm using 1/16 inch filler rod diameter, or if you want 0.35, you could feed out a little bit of MIG wire from the MIG and use that if you want something a little thinner. My method is to, with that same clamping of the aluminum chill block, first do a little dab in that top corner, on the outside edge that's fragile, and then I'll weld from the bottom up. You can use whatever method works well for you. In fact, this vertical up is a good technique to know how to do, and I'm just manually pulsing with my foot. But you can lay this part flat, clamp it in whatever position works best for you, and take your time with it. Run some practice pieces, and you'll get it the way you like. That chill block allowed me to get 2 welds, using the MIG and or the TIG, and I didn't get any burn through on the other side, and the shielding gas also flowed in the back. So those are the methods using the 2 arc welders we've got. Here we're gonna clamp it and fixture it for the spot welder, and first thing is to just put one of those corner tabs on, and if your part is a little bit open like this one is, just grab a longer clamp, and whichever one works for you. You could use a little bar clamp and squeeze the 2 parts, the 2 short legs together, and then we'll use this welder style clamp to hold the other leg in place. Once they're in good position, we can remove that earlier clamp you used to squeeze it. Here's the resistance spot welder. Wheel it over to one of 2 plug-in locations, one of which is where I am, which is behind the larger pedestal grinder. It's a 220 20 amp receptacle that you'll need in order to power this machine, and there's 2 of them, one behind that pedestal grinder and one by the bandsaw. Clamp your part into the pinchers, and it's a sideways motion with that trigger, and it's a momentary trigger. It only welds or delivers electricity while you're actively pressing it in. So if you press too long, you can burn a hole clear through your part, and if you don't press it long enough, you won't get good fusion. The other thing that you want to make sure in order to get good fusion is that your sheet metal parts are nice and flat and right up against each other where the electrode is pinching it. So sometimes additional clamping on either side or taking a little time to fit up your parts properly, making sure they aren't too mangled or wrinkled is real critical in order to get a good spot weld. You can see I'm just doing 3 good ones on either side of those corner tabs, and then taking my time, and it's just a moment or two, maybe like a 1/1000, and then that's all you need to zap it on there. Now we're going to fit up this tray. You might have to do a little bit of squeezing. I've got a nice tight fit here, and make sure that again you're getting good solid contact between the ends of your tray and the vertical legs of your part, like so. And I've used those pincher style clamps, vice grip style clamps, offset a little bit so that I can feed and reach in there with the electrodes of the spot welder and get the 2 legs in there. I'm just going to do 2 little spot welds on either side of the handle, and that should be enough. If this method proves to be a little too difficult, there's another method which I don't have shown in the video, but you could drill a couple of small holes and use a pop rivet, or even find some sort of a block to put in there and use a traditional rivet and kind of hammer and peen it over. I'm using the spot welder for these. It is probably the fastest way to join a sheet metal box together, and is pretty sturdy if all goes well. And here you have your finished box. I'm going to take a little bit extra time to clean it up. You may want to grind the welds down at the corners. The spot welds are generally just kind of left as is. You could put a coat of oil or paint or something on there, and your finished box should give you a good long rust-free service. And here you can see the different corners that we've welded together with the MIG and the TIG, and a couple of spot welded corners, and you'll be able to carry around your basic fabrication and layout tools, some clamps, gloves, some setup blocks, and the top tray is great for holding scribing and marking tools, and it should make life a little easier in the shop for you. So make sure you observe all the safety rules when working, and listen to your instructor and the shop monitors, and be safe working in the shop, and have fun with this.